today. So let's get started. So welcome to the webinar today on best practice in creating a quality CI/CD pipeline delivery. The webinar today is by Test and Verification Solutions, which is now part of the bigger TestSolve group, and we deliver innovative embedded hardware and software design and testing capabilities. Also introducing our new automation partners, Leapwork. The presenters today from T&VS TestSolve is myself, Brian Lowen. I'm a senior QA professional with over 23 years experience. And also Monica Kaduri, who's our estet for T&VS today, and she'll be talking you through Jenkins integration and best practice. I'd also just like to introduce, as I said, our partners Leapwork. So Suna, would you just like to have a quick introduction?
Yes, certainly. Thank you, Brian. Hi, everyone. My name is Suna. I am Senior Evangelist at Leapwork. So my work on a daily basis is helping clients, both prospect as well as existing one, getting the best possible start to automation. So very happy to be sharing our insights for you here today. Thanks.
Okay, thank you, Sune. So just to confirm the timings today, we're aiming for roughly 40 minutes with a Q&A at the end. Please post any questions on the chat forum as part of the webinar and we will pick them up, or afterwards, if you've got any queries, we will come back to you. Okay, so let's get started with the webinar. So the aim of the webinar today is to demonstrate best practice in creating a quality CI/CD pipeline delivery. The agenda is: first, why do we need a CI/CD? 2, benefits of continuous testing and best practice. 3, tips on integrating Jenkins server. And finally, 4 is selecting the right automation tool for your company. Ultimately, we want to show you how automation testing can enable a quality CI/CD pipeline. So let's have a look at why do we need a CI/CD delivery model. The traditional model of delivery is always very slow, rigid, and cumbersome. These are exactly the type of challenges a good CI/CD pipeline starts to unlock. The reasons companies are looking at this type of model is to keep up with this ever-increasing demand for change. Delivering a secure and quality product is becoming increasingly difficult with more systems, more devices, and all with increased complexity and faster changing environment. But in parallel, the cost of getting it wrong is also increasing. Not performing the right level of testing could leave finding defects in the hands of your customers, risking brand damage or even lost revenue. So is CI/CD delivery pipeline the answer? The reliable, fast delivery process that we all crave. So let's start with this whole CI/CD process definitions. So continuous integration is merging the development work with the main branch constantly. Continuous delivery of the code to an environment once the code is ready to ship. Continuous deployment of the code to production as soon as it is ready. The overall process of CI/CD focuses on software-defined life cycles, with a real focus on tools and an emphasis on end-to-end automation. The benefits of CI/CD can be realized if quality is integrated from the outset and not just an afterthought. So some of these benefits are immediate bug detection, so you get the feedback loop quickly, no integration steps in the life cycle, a deployable system at any given point throughout the delivery, and a record of the evolution of the project and the delivery. CI/CD can deliver fast changes straight into production, but only if you set up a full end-to-end delivery pipeline. The following shows some of the different stages you can go through to build this. So stage 1 is where you've got no build servers, the developers commit on a regular basis, the changes are integrated and tested manually, and you've got fewer releases. Then you evolve into stage 2, where you've got automated builds are scheduled on a regular basis, the build script compiles the application and runs an automated set of tests, developers now commit their changes regularly, and the build servers will alert the team instantly on a build failure. Then into stage 3, a build is triggered whenever a new code is committed then to the central repository, and any broken builds are picked up quickly and looked at. Stage 4, automated code quality and code coverage metrics are then introduced and run along with the unit test to continuously evaluate the code and give that feedback loop. And then stage 5 is obviously full deployment, where the software is then automatically deployed straight into a production environment. So continuous testing is essentially automating the CI/CD delivery pipeline. So what is continuous testing? The main objective of CT is to serve as a feedback engine in a release pipeline to, one, improve quality assurance, and two, increase the speed of their delivery. It also goes beyond automation and encompasses all practices, including tooling and even an overall cultural change. And a key point is, you can only deliver as fast as your slowest asset. So overall, CT is a change in mindset. And a couple of these points here go into a bit more detail on this. So first thing is it's a shift left. So it's all about finding the defects as soon as possible, as soon as the code is produced and as close to the origin of the integration of the defect. You want to give instant feedback, so developers are getting reviews and the quality of their code instantly. 24/7, you've got a current available build. Immediate testing, so automation at a number of different levels. Less complex code, so it pushes developers to create more modular code. Quality focus, so all hands, when there is an issue, the whole team look at why, where, let's get it fixed, let's get this system back up and running. Full automation, so no manual steps involved, and the quality of the test as well. So the CI process depends highly on the quality of the test and what coverage they're actually covering across the system. So automation levels and feedback, as the previous slide suggests, is essential to build in a number of automation levels and give that instant feedback loop. As you can see, this diagram shows a number of different sort of automation levels. So you've got the delivery team, they check in a new piece of code, it triggers automatically a build or unit test, that fails, feedback goes straight back. You then got, they check in a new version, that then passes the unit test, goes to automated acceptance test, that then fails, it goes back, and so on. So you start to see there how we're building some different layers, but also shift left, looking at trying to find the defect as soon as possible with code and unit test sort of coverage. So finally, from me, these are just some of our principles for automation testing and continuous testing. So one, every build should be looked at as a potential release. Two, automate wherever possible across the system. Certainly, three, eliminate any manual bottlenecks, otherwise it will slow you down. You can only run as fast as your slowest component. And then four, finally, which is automate tests you can trust. So I'm now finished on my section, and I'm going to hand you over to Monica, who will talk you through integrating a Jenkins server and tips and how to set it up correctly to maximize your QA delivery. So just bear with us for a second while I change presenter and I pass this across to Monica. There you go.
So I believe you are able to see my screen, right?
Yes.
Okay. Hello, good morning, everyone. Today I'll be presenting overview of Jenkins, starting with what is Jenkins. Jenkins is an open source continuous integration server capable of orchestrating a chain of actions such as automating the build, artifact management, and deployment process in an automated fashion. Jenkins' core functionality and flexibility allows it to fit into a variety of environments and can help streamline the development process for all stakeholders involved. Moving on to the question. Why Jenkins? So beyond Jenkins, there are many other CI/CD tools available, which are open source like GOCD, Conco, Screwdriver, and managed tools like Travis CI, Circle CI, etc. But Jenkins is a leading award-winning open source CI server, which holds top position in DevOps tool chains due to being free, open source, and modular. Jenkins is a self-contained Java-based program ready to run out of the box. It's easy to set up and configure Jenkins. With around 1,400 plugins and development center, update center, it integrates with practically every tool in the CI/CD chain like Git, SVN, Subversion, Slack, Jira, Selenium, you name it and it is there. Also, Jenkins supports frequent releases with little or no interaction or even knowledge of users. And Jenkins is repeatable. It means we can go back to the same version of code as input. We should get the same set of deliverables. And Jenkins is distributed. It means Jenkins can easily distribute work across multiple machines and multiple platforms faster by using Jenkins master-slave architecture. where master is a main server that schedules build jobs, dispatches the jobs, and monitors the slaves. Whereas the slaves are the remote machines used for distributing software builds and test loads. And also master records the build results. And coming to the Jenkins features, Jenkins runs both on-premise and cloud as well. It can execute Apache Ant and Maven-based projects, arbitrary shell scripts, Windows batch commands, and many more. It provides job models like freestyle, Git, upstream, downstream jobs, etc. Also, it supports any Java supporting platform like Windows, Linux, Mac OS, and many more. And Jenkins allows us to use container technology such as Docker to create isolated build environments, so that we can easily scale up or tear down environments that have variable workloads. And it handles error conditions and email notifications. And it also implements an acceptance stage in the middle, which means we can promote the build to production only if ServiceNow change ticket is approved or by manual approval. So there's a checkpoint there. And also it helps with database migrations, data synchronizations, and many more. And we can get continuous feedback on feature branches using Jenkins multi-branch feature. And coming to the Jenkins plugins that can enable wide range of features across various stages of CI pipeline. Jenkins has around 1400 plus plugins, like I said before. Few of these are here, and we'll discuss about the most used in the next slide. Yeah. Here, so Jenkins supports version control systems like Git, SVN, and many more. And it supports build tools like Maven and continuous testing tools like Selenium, Appium, LoadRunner, and many more. And configuration management tools like Puppet and continuous deployment tools like Ansible and monitoring tools like Nagios. And coming to the setting up of Jenkins. So we just need to install Java and download Jenkins repo. And we need to install the required plugins. And we need to define stages, like, for example, build, test, deploy. These are the stages which contain executable steps. And then we can do code review using tools like Gerrit. And we can configure unit testing frameworks such as JUnit. And we can have test coverage tools such as Jepoco, SonarQube. We can integrate with them. And there's a post section which defines which actions to run at the end of the pipeline, like reporting related and email notification if pipeline fails. And we need to do all the setup, and we are ready to go. So this is a sample pipeline where it runs all the stages, like getting release version, building Docker image, uploading it, and so on, as you can see, with every commit as well as periodic runs in the left side. And it looks like this once we set up the pipeline for every commit. And coming to the best practices, we suggest some of the best practices that we follow, including but not limited to this. So always authenticate users and enforce access control, so that helps us secure passwords, certificates, and other private data. And also you need to prevent jobs from running on the master node. Otherwise they'll have unrestricted access into the Jenkins home directory. We need to be careful about that. And you can do this by setting the executor count to 0 or running it on the agents. And many tools cannot handle spaces, $signs, and some characters. So you can define a pattern of project names in a section called configure Jenkins, so that there's a restriction on all of your users on setting up project names. And also Jenkins supports file fingerprinting to keep track of which version of tool is used in which build and all that. And to ensure a build can be reproducible with all code, including third-party jars, build scripts, release notes, etc., it must be a clean build every time, which is built from source code control. And we need to integrate it tightly with issue tracking tools like Jira and all, so that it will reduce our need to maintain a change log. And we need to archive unused jobs and set up different job for each branch. So these are some of the best practices. So handing over to Sune now. I'm done with my overview.
Yep, thank you, Matika. So happy to share with you then the next story, which of course is in the huge context powered by Jenkins, then focusing specifically on that important step of software verification, which of course is testing. So talking a little bit about how those consideration specifically around testing is relevant for you guys, because obviously Jenkins accommodating to all steps and stages throughout your delivery process and all types of tests. Obviously, when looking at it from automating your testing, you need to be aware of the types of tests that you do and which tools you need in order to automate all of those, because needless to say, if you want a successful CI/CD pipeline throughout, you need all steps automated within it. And it's important for me to say that, looking at test automation, it's very often a case of having more than one tool for the job, because as I'm sure you're aware from your quadrant knowledge, the delivery quadrant, you have different types of tests, and the traits and skills needed to do these tests are very different. Some of these tools out there won't even actually accommodate themselves very well to continuous testing, so you need to be aware of that, of course, as well, while choosing and making your considerations. And a very important point, and one that I'm going to be repeatedly coming back to in my presentation, is you have your testers already in the organization. They may or may not have technical skills. If you have proficient functional testers, you really need to be aware of and be attentive to what it is that you want these testers to be excelling at. So currently, I'm guessing they're there because they are very good at pinpointing holes in your applications, and really that's where you want them to be, rather than having to teach them to code, as an example. And obviously, whenever you do automation for testing, you need to have a way to ensure that your entire team can collaborate successfully on doing automation, and not just restricting it to some people working in the corner. So those are some of the things that we're going to be talking to. So again, re-summing it up in terms of what to consider. Obviously, what types you are testing, of course, also speaks into that. Can it integrate into various tools out there? How fast do you want these things to go, both in terms of building and orchestrating automation, certainly also obviously running it. How fast can you get it up and running in terms of skills and competencies, and of course also speaking into what will this do to the way that you do deliver your software and those touch points to the rest of your organization. So that's what we're going to be talking about, and I'm going to be introducing in that context this tool we call Leapwork, which is designed to accommodate the requirements of facilitating fast and efficient automation in testing. And speaking of testing, speaking of regression testing, certainly I'm sure most of you will recognize the fact that working with regression testing is a repetitive, a boring task. And the problem with those types of tasks, of course, is that themselves sort of generate errors, because people get sort of distracted. They lose focus, they lose their eye for detail, which of course is a problem when doing QA. And it's not really making anyone happy to do these types of tasks. It's not really something that, yay, I'm going to spend my full day doing regression for nth time. So that's another dimension to it, being able to also satisfy that work quality perspective from the perspective of the employees. And really what we're talking about is, because obviously the employees is the key, we want to be creating an agenda where you can make automation something that more members of your teams can actually contribute to. And the key problem there is that most automation tools out there requires you to be able to code, which effectively locks it in, or as we say, prevents it from scaling, because scaling in this context means how many people can you actively include into your automation agenda. Our suggestion, our proposal for this is to, rather than looking at code, then moving towards what we call the next generation visual language, which basically makes it possible for technical as well as non-technical people to actively work on, so collaborate, contribute, and ultimately drive the automation agenda, where it is no longer a prerequisite to be, a fluent developer, but really, first and foremost, being able to understand the business process, understand the business applications, and how these two things interact with each other in order to deliver the expected product or the expected service on behalf of the organization. And this visual language, we are really wrapping into, we use that as a wrapper rather, to make sure that irrespective of you working with a given technology, so if it's running in the browser, it's running on the Windows desktop, it's SAP, it's something completely different, it's the same way that we express automation. It's the same way you as a user needs to understand automation. So, figuring out how to automate these different things from a technical perspective, very different activities. from a Leapwork perspective, we want to keep it the same way, obviously, to make sure that it becomes as easy as possible for the users to contribute and join into the agenda of automation. So that's what I would like to show you, how we do that in practice. So very briefly, use case is about very representative test case, of course, which is to log into an application. So millions of tests all over the world starts with just that. So we're going to be showing that. And then obviously, once you've done that login with a given set of credentials, how you then assert that the login has been successful with that particular set of credentials. We're going to be using Salesforce for this example. And then once I've done that, I'm going to be, taking you onwards in terms of saying, well, here's this beautifully automated flow. Let's take it all the way in terms of best practice. I'm talking about reusability. I'm talking about parameterization. And then to wrap it up, how do you fit that into an orchestration context? Obviously, with Jenkins sitting in the control tower, how will Leapwork accommodate itself into that particular context? So with that out of the way, I'll just jump into Leapwork. This is the Leapwork application. This is where you build and design your automation flows. Let me just make it a little bigger for you here. Here we go. So I'm not going to be spending too much time, of course, taking you through all the gory details. Here lives the automation flows that you build over time. Here is what we call the canvas. This is where you design and draw automation. So if you please take into your mind that drawing I showed you previously of that visual language. This is what I'm about to begin to build. Today, I'm going to be doing it using the built-in recorder feature of Leapwork. The outcome of that recording will be that Leapwork flow, and obviously I'll come back to that in detail later on. So when I hover above this building block, which is there to just clearly show you where things begin, click and drag from this connector here, and you can see us starting that drawing process, if you will, of business processes. So from this menu where I have all of the individual building blocks, which would correspond to the boxes in the business flow, I can now start to design and draw my flow. So I'll go ahead and do that, again, using the recorder. So when activating that, Leapwork leaps into the background, literally. And now I have a recording widget down here in the bottom. So I'm just going to use that to start the application. I'm going to choose web for this, of course, this being Salesforce. And all I need to do now is simply enter where I want it to go. So I'm going to do that, salesforce.com, click start, and then we'll just have to wait a second or three for Leapwork to successfully launch the browser and then subsequently navigate its way to salesforce.com. We'll take a few seconds, here we go, and then navigating to the login page on Salesforce. So now the business use case again, I want to log in. Notice that we've gone into sort of what we call it a capture mode. So the mouse pointer is converted into this crosshair, and as you sort of hover above the individual elements, you see them lighting up. So as the business user, the non-technical user, it literally becomes a case of just point and click. So I'll point on the username field here, and Leapwork will inspect it and nominate actions that you could do, and it'll try to put the most likely one on top. So you can see type, which is exactly what I need to do. So I'll enter the username in this one. Here we go. And click apply to actively put it into the field, continuing then onwards with the password. So I'll click on that field. Again, it's a type action suggested. This time, of course, I'm going to treat it as a password. So I'm going to enter that into the field here, like so, click apply. And then we're ready to do the actual login. So obviously I need to click on the login button. So I'll proceed to do that. And this time you can see it's a click action nominated as the most likely one. Which type of click is it that you want to do? Obviously, you need to designate that as well. So I'll choose the left click, proceeding to click on the login button, and now just waiting for Salesforce to do its thing, logging in the user, taking a few seconds here again. And now that it's completed the login flow, you can see the page is immediately ready for you to do continuous inspection of these elements. Again, recapping the use case, I need to assert the login correctly done. So I'm going to be looking for a profile name to verify that it's the right profile coming in of the credentials that I provided previously. And in Salesforce, it's sort of hiding up here in the corner, clicking on the mascot. So choosing a click on that, which will bring forward the profile menu, and then I'll ask it to look for the profile name. So tell Leapwork to find that. And once I've done that, I'm actually done. So I'll return to the widget down here and click save and close. And what comes out of that is then the completed Leapwork flow. So as you can see, a business flow that step by step takes you through these actions that you need to do. So launching the browser, typing in the username and the password, all being sort of visualized in this business process type of way, and having visual elements to support the understanding of where it is that you are in the automation process. Let's just take this out for a spin and see if it actually works. So at any given time, of course, you can run the flow either from specific individual building blocks. I'm going to run this one from the very beginning, so I'm just going to hit the play button here, and Leapwork will shut down the existing browser, launch a fresh new one. And again, we'll just have to wait for a few seconds for it to completely launch. We're using Selenium, so we're sort of activating, if you will, the Selenium framework under the hood, and now continuing to do the automation steps, clicking on the login button, waiting for Salesforce to complete the login, and then looking for that profile information at the top of the screen, and then concluding the run. And once the run has completed, what I want to show you is then how can you then do efficient debugging to work your way through understanding if the flow has failed or not. So just quickly jumping to the reporting section here, I'll show you this is the run that I just did. So you can see the flow right here. And what you have down here is the video recording being made available for this entire run. And what you have over here is the event log, so detailed describing to you what's going on as you are driving the process from A to B. And of course, also you have the canvas with the building blocks in it. And do note that when I scrub through the video, both the log follows suit interactively, so to speak, as well as the canvas. So this one up here is lighting up. If I move forward, then you'll see that lighting up progresses as well. And the point here is to say, when you have these three tools available, you have the video recording of the flow, you have the detailed log, and you have the building blocks lighting up, then debugging, so figuring out in the event of failure, why did it break, becomes very fast indeed, because you literally just go to the failed event, look at the last light entry, that building block lights up, that's where your debugging begins. Right, so just wanted to share that feature with you. So going back to the flow, and what I want to do now very quickly, take you all the way towards best practice, because obviously, as you'll note, this flow is hard-coded using my credentials and also finding my specific profile. So starting with the reusability side of things, which is the story about saying, here's me building a functionality, I'm going to be using this again and again. So obviously, I don't want to build this every single time. So what you do is that you select the building blocks that does the work for you that you want to reuse. I'm going to choose these 4 ones here, right click, say create subflow. I'm going to call this login to Salesforce like so, click save. Now, first and foremost, what you'll see is that it's all wrapped into one single building block. And this building block is now available from the building block menu. So if I just type login to Salesforce, you can see it pops up. So you can now literally add this entire functionality just with a click of the mouse. Now, secondly, taking that hard-coded aspect away from this flow. So different ways of driving data into it, because obviously that's what we need to do. We need to parameterize this flow and use external data to run it. So what we'll do is adding an external data source. There are different ways of doing that. So you can take a database. So any database that is ODBC connected to your system, you can apply and use for bidirectional automation. It could also be that you have an API or maybe a web service. You would then use this building block to attach yourself to that. Or you may have something running in PowerShell, or there might be an executable somewhere, and you would invoke command line to activate that. For this demonstration, though, I'm just going to be using an Excel sheet because obviously that's what is very familiar for many users out there. So here's a building block that's going to read an Excel sheet. Step 1, of course, to configure it to work with the relevant files. I'm just going to point to a file. So I have one here in my, on my desktop folder. Just need to locate that. Where'd she go? Here she is. Just so happen to have a bunch of Salesforce logins here. So pointing to that, and then next visually defining, okay, which portions of this sheet do I want to use? So just do a selection as you would in Excel. I'm going to check this one, then Leapwork knows that the first row is actually the label, if you will. So when I click save, these are now made available here in the building block. Now, step 2 is to actually make a little room for this building block to be a part of the flow. So I'm going to go ahead and do that. So I'm just going to scoot this. You can see how flexible this environment is. I'm just going to move these a little bit to the right and add the Excel building block, rewire these green connectors to actively include it into the flow. And then what you need to do next is actually obviously apply the data. So now you just take the username and drag it into the login flow like this, and follow it by the password, put it in there, there you go. And then the last step that I quickly want to take you through is then sharing with you, okay, then how can you then also parameterize the assertion bit? Because obviously in this previous example here, I'm simply typing stuff into an empty field. This is me looking for something in the application. So obviously I need to modify the strategy here to make sure that it'll work with any profile name being sent at it, which means that I need to manipulate with the locator strategy. So when I click edit, the strategy editor appears. Now the strategy editor is by far the most advanced part of Leapwork. This is where you can make all types of complex use cases, working with data, working with different locator strategies. You go here. If you want to iterate your way through huge containers of data, either in the browser or in the desktop application, you go here and facilitate those use cases. Now for this simple one though, what I'm going to be doing is simply looking for a way to parameterize the profile name. You'll see that here, this is what it's looking for. These are different strategies. So when I capture something, Leapwork will calculate different strategies on the spot. So it'll make it easy for you to do some different choices depending on the use case. And what you have here are the individual conditions which are relevant per strategy. So if I just do a quick browsing over here on the left, you can see this strategy here actually holds my profile name here in it. So obviously this is just what I need. So I'll just go ahead and right click on that and replace it with a field like so, and click save. That field is now available from the building blocks, and I can just take that from the data source as well and hook it up like that. And obviously to conclude it all, telling Leapwork that once we're here, then we've actually done a good day's job. So I'll just say, this is what it takes to pass the flow, and we're done. So this is how you build automation in Leapwork. This is running in a browser, and as I said previously, once you've figured a way of using these building blocks for these particular elements, you can automate across all types of technologies. It's going to be the same way that you do it. It's going to be the same way that you hook up data sources, et cetera, et cetera. So again, talking into the learning curve and the ease of application of automation. Now, the last thing that I want to touch in on is to say then, how do you then orchestrate this in a CI/CD context? Because obviously we're only automating tests here. So what I want to share with you is how Leapwork will service and support that agenda as well. So you go into scheduling in Leapwork, and let's just say that we've built something that will cater for our regression needs, a typical use case for that one. Obviously starting out with saying, well, I want these flows here or these entire folders to be part of my regression scope. So whenever it is, please run this. Obviously, you also need to designate where to run them. So it's probably close to production since we're doing regression. But anyway, here goes on pre-production, so we'll choose that. And then obviously also when Leapwork has run the schedule, you can have it communicating with you based on some different conditions, as you can see. So for instance, when the run is completed, please either send me a mail, communicate to Teams, or run some teardown, for instance, through PowerShell. All of these options are available to you. From this feature, you can populate the email with parameters and variables, so it becomes something that is dynamic, reflecting exactly the instance of the schedule run. And then lastly, what type of schedule do you want to do? Leapwork will support both use cases. So if you do scheduled, it's going to be a classic scheduled context of saying, well, please run this every weekday at midnight. Of course, talking about CI/CD, we want Jenkins to run it for us. So that's why we switch it to ad hoc. Now, basically, this schedule will be made available through the API, Jenkins can just, give out a shout, and Leapwork will start running, execute the tests. And obviously, in the other end, of course, also integrate seamlessly into Jira or other types of applications to create that bug, facilitating that automated feedback loop. So crucial for your successful CI/CD implementation. Right. So based on that short demonstration of Leapwork, let me just go back to PowerPoint land to briefly sum up some of the pointers to do. So talking about, okay, here's an automation tool that you can consider. That's good. You're not done yet though, because automating the specific tests is just a part of it, but also understanding that automation is really an agenda of its own. It's a completely separate domain. So the tool is only a part of that. It's similar to saying that here's Word, Microsoft Word, then you can do easy writing now, but it doesn't turn you into a writer, right? So you need to understand the domain. You need to be proficient there as well. So it's very important that you understand that. There are preparations to be made, there are skills to be secured into your organization. So some of those key preparation points, just highlighting one or two. Figure out what skills you have, going back to, you have functional testers, make sure that they will be keeping on excelling at that. Understand where you want to automate, think big, but start small, and work your way through a structured plan leading up to having a very clear strategy, what it is, where do you want to be after, for instance, year one, so that you don't simply just start automating everything. So those are some of the tips that I wanted to just briefly share with you. Right. So Brian, back to you.
Yeah, thank you, Sune. That was very good and very useful. So yeah, let's just wrap this up. I think we're pretty much on time. So just to summarize some of the points from today. So if you are going to build a CI/CD delivery, then you want to ensure you get the instant feedback to gain the most benefit. Obviously with a focus on shift left from a QA perspective, so you find those issues early, you can then identify them, get them fixed, and then push through the pipeline quicker. Jenkins we've touched on, thanks to Monica. So obviously it's very flexible with many features and plugins, so it really is an integral part of any CI/CD system. And finally from Sune, so he touched on, I think if you are going to look at an automation tool that's right for your organization, so our first recommendation would certainly be, define your requirements. We've given you a bit of a checklist there. We can certainly help you do that if you need to do further. So you really understand what you're looking for in the right automation tool. And then also looking at a long-term strategy. So consider how you will achieve that over the first year, etc., so that you can get a fully automated pipeline with no manual bottlenecks, basically. So, okay, well, thank you for that. So if you just drop to the next slide, Sune, I think we've got some Q&A. Some people have been kindly asking some questions, so let's just touch on those quickly. Actually, the first one I've got for you, Sune, is around Leapwork. Can Leapwork be used for a Unix terminal or Linux, etc.? Do you know, or can it be, basically?
Yeah, thanks for that. Well, certainly Leapwork is used to automate terminal applications such as mainframes or Linux prompts. So the answer for that is yes. I should, though, make it very clear that Leapwork itself is a Windows application, so it will require Windows boxes to run from, but it will be able to access any sort of systems from there. So the short answer is yes, but do be aware that the application itself is Windows-based.
Okay, thank you for that. I've got a question from Monica now, which is, can Jenkins be used for functional testing? Monica, you might be on silent, I don't know, but can you answer that?
Yeah, Brian. Actually, we can use it for various types of testing, not just functional, and definitely yes, and then integration and load testing, performance, and we can use it for various types of testing in a single pipeline. Yeah.
Okay, thank you. And let's do one final question, which is another automation one, I think, which is a key one for me, I think, from Leapwork side. So obviously there's many free open source automation tools out there. Sune, so why should I use Leapwork when I've got all these other options which are free and Selenium, etc. So what's the
Certainly a recurring question. I agree on that. So yeah, exactly. Why go for a product like Leapwork when you have all these free options available to you? And I think the short word is that many of these free options will either be fairly hard to use, so specifically only available if you have that coding competence and skill set available to you, or they are service based, so meaning that typically they will be running from the cloud. And obviously, if all your stuff is cloud-based as well, that'll probably work fine. Many clients, though, in our experience, have obviously a lot of stuff running on-prem, and just opening up the gates, so to speak, through the firewall for that external service to access crucial systems, albeit may potentially just in your QA environments, but still is something quite frequently frowned upon in many organizations from many different perspectives. And typically you'll also find these free tools only able to do a specific thing. So for instance, this supports web, or this supports a very specific application technology of what it is, whereas we strive to cover the full palette of stuff that you could ideally do from an automation perspective. So web applications, and as we talked about previously, terminal windows and stuff like that. So that will be only a part of the answer, but obviously I also want to give some time for other questions as well.
Okay, well, I think we've probably reached the end of the webinar today. I think we've covered quite a lot of ground there. I think there are some further questions which we will try to attempt, and we'll come back to you separately if that's okay. If you've asked them, we will pick them up and come back to you. But hopefully that was useful. You've got some good information to take away there, and obviously if you need any further information, then please get in touch, but I will finish the webinar now. So thank you very much for attending today. Thank you.